Okay, so smelting reduction can be categorized or classified in two stages. One is the single stage smelting reduction and second is two stage smelting reduction. In the single stage smelting reduction, it is shown in this figure. So, in this one coal and oxygen is fed into the reactor along with the ore, and the combustion, reduction and the melting occurs in the same reactor, and you separate out the metal and slag and the product gases goes out. So, everything occurs in one reactor. So, that is why it is called single stage smelting reduction. However, in the two stage smelting reduction, you have the coal and oxygen as an input, and you fed DRI actually. It is sort of a reduced iron, not exactly that DRI would be having 94 or 93% sort of metallization, degree of metallization as we discussed before, but it substantially reduced DRI, and this is also fed into the smelting reactor, and where this smelting occurs, so slag and metal separated out, and the product gas which have the high caloric value and reducing potential, they are used to reduce the ore in the another reactor. So, this is like a two stage process. So, in the first one you have a reduction of iron ore from the product gases which are coming out from the smelting reactor, and in the second reactor that reduced DRI is fed along with coal and oxygen, and the smelting occurs and you get the liquid metal and slag. So, this is the basic difference, and most of these smelting reduction processes are in the second one. In the starting it started with the first one, but later on mostly second one was adopted. One of the probably previous example in the starting high smelt or like that, but later on they have been modified. So, we said in the starting about in the starting of a smelting reduction lecture, we introduced two terms, slag foaming and post combustion, and we said we will just talk a little bit about it later. So, here we are, that usually in the smelting reactor, as you know, most of the reduction occurs in the liquid stage. So, you have a solid iron which is feeding fed in, and you have a slag metal. Slag has quite a high percentage of iron oxide. So, carbon is injected into the slag and it reacts with FeO to form Fe plus CO, that we had seen before in the reaction. And when the CO is forming, so CO is a gas and it has to bubble out through this slag. So, and it is a very intense reaction. Remember, because in some of that we mentioned 80% FeO and in some 20 to 80%. So, very intense reaction takes place. So, lots of CO generation happen, and that actually CO has to bubble out, and that gives a sort of a forming reactions. So, it expands, it makes the slag as a form one. So, that is called the slag foaming. So, that level rises of the slag and the metal also entrapped into this, the droplet. So, that is called the slag foaming. So, in one way it is insulating the metal from heats and other thing. So, act as an insulated, keep the temperature. So, this phenomena is slag foaming. On the other hand, if when the CO which is forming in this intense reaction. So, CO, as you know, it has a high calorific value, it can be burned because oxygen also in the reactor, it is a closed reactor, let us say. So, oxygen is also introduced in this. So, CO react with the oxygen and gives CO2, and that is a very exothermic reaction, lots of heat is produced, and this heat actually that is burned. So, CO is burning here, and that heat is being utilized to for the melting purpose in the reactor. So, the heat which is getting produced by burning of CO at the top of the reactor, but inside the reactor is known as the post combustion. So, in one way you are combusting the gases and utilizing the energy of this to heat up the scrap or matter or scrap, any of these things. So, you are utilizing that heat, and that is why it is termed as post combustion. Mostly it is in a single reactor it occurs, and one good example also steel making, basic oxygen furnace and like that, where post combustion and other things occur. So, this is the meaning of post combustion and slag forming, and especially in smelting reduction processes, these are quite common in smelter reactor. So, CO bubbles pass through the slag and forms a foam known as slag foaming. CO thus generated is oxidized to CO2 in the upper part of the reactor and produce significant amount of heat before leaving the reactor, because that is a exothermic reaction. So, this is known as post combustion. So, now I hope you are familiar with the terms of slag forming and post combustion, and these phenomena are quite common in most of these smelting reduction. So, now that smelting reduction process can be divided in different categories. Those processes which are based on shaft furnace, these are like COREX, Sumitomo SC, Kawasaki SF, FINEX. So, these are based on this shaft furnace based. Electrical processes, some processes use also electric as an energy source. So, like INRAD, LRAD, combi smelt, plasma smelt, these processes and some other they use electrical energy besides the other. And the third type is converter process, where you have a single sort of converter in which the smelting occurs. So, Krupp, coin, high smelt and high Sarna, these are the processes which comes under these. So, only few processes which have been commercialized, we would be again just talking a little bit about those processes and leaving the other processes. So, COREX is a quite commercialized process which has many plants all over the world now. So, first commercial smelting reduction process, operating in many countries like South Africa, India, China, etc. Feed is closely sized 6 to 20 millimeter pellets and lump ore. So, remember in this one you have to feed as pellets or lump ore. So, it does not take fine, this is the difference in this one. Operates at high pressure up to 5 hours, it has a quite high productivity. Reduction and melting takes place in two separate reactors. So, it is a two stage process. Coal 6 to 50 millimeter size, 50% above 10 millimeter is charged into the gasifier section. So, there are some requirement of the charge which should be in those sort of range, and so this process is sensitive to these charges, but nonetheless you can see it uses coal and pellet, so without using the coke. So, the flow diagram of this process is like this. So, you to introduce the oxygen and the coal. So, oxygen from the bottom, coal from the top, and the dust also which is generating into it, you can put away a little, and smelting occurs in this reactor. Depending how much post combustion you need, you can put the oxygen amount accordingly, because otherwise even this energy is used for the reduction of the furnace, reduction of the iron ore. So, iron ore is fed into this reduction chamber in that reactor, like a shaft furnace type reactor, and reducing gases which are coming out from the melter gasifier. This is known as melter gasifier. So, the reducing gases which are coming out after removing the dust and other things are fed into this reduction chamber, and the ore get reduced, and these reduced ore are fed through the screw feeder into the melter gasifier, and this hot so sensible heat even of this reduced gas is also being used into this, and then the smelting occurs into that one. And because oxygen is used here, most of the smelting reduction processes use oxygen. So, their off gases have very high caloric value. So, top gases mostly they are used in the plant for all the power requirement, but still they have a very high calorific value. So, they are used for power generation and export those electricity or gases for other purposes. So, this is a typical diagram of the COREX process, and as I said, this is one of the most popular commercialized smelting reduction process nowadays, which is having a few plants in some of the countries. However, the productivity is not as high as the blast furnace. Another process is FINEX smelting reduction process. So, fluidized bed, this is a fluidized bed. So, this one because it is a soft bed, packed bed sort of one. So, here ore is not fluidized, and those pellets are getting reduced and being fed into melter gasifier in that one. So, this is in the form of pellets. However, in FINEX one it's a fluidized bed based reactor. So, usually you can use the iron ore fines in this. So, size of this ore would be low. So, POSCO South Korea steel company actually had developed this process. This essentially what they did, they studied the COREX process, they bought the COREX plant and they modify that process and introduced the fluidized weight, and that is how they came up with the FINEX process. So, it uses iron ore as I mentioned, so less than 8 millimeter. So, it can use the fines and same way the coal fines also. So, major advantage of this is using the fines, because lots of fines are generated from mining till the melting operation, and those becomes a problem. Then you have to use the agglomeration technique, pelletization and sintering plant, and extra investment in iron making processes. So, this eliminates the agglomeration plant also altogether beside the coke oven, because it is using coal. So, no coke requirement. Pre-reduction in fluidized bed and melting in melter gasifier occurs. So, again a sort of a two-stage process. So, pre-reduction in one reactor which can have a series of it and melting in melter gasifier, and commercial plant in operation is in operation in South Africa at South Korea at POSCO. So, this is a flow chart of the FINEX process, where again melter gasifier is there to put the oxygen and other gases. Essential features are more or less same in most of these melting processes. So, this off gases actually introduce into the fluidized bed reactors which are in the series, and by the time it comes out from the R1, that you get almost quite reduced iron ore. Now, because iron ore it is fine in nature, so it has to be briquetted. It is difficult to put it directly. So, hot briquetting is done of this one. It comes and through that hot briquetting machine, and these hot briquette are fed into the melter gasifier, and this is similar to the COREX process. This melter gasifier, so no need to describing it again, and these recycling sort of gases goes again for the reduction purposes and even some off gases, and because here also one is using oxygen which has very high amount of calorific value and energy. So, used for power plant and other purposes, and it has even some CO2 removal plant.